In this video we'll show you how we can create a chamfer or a beveled edge on this DXF file. So the edge that we're interested in is this one down here. So this is a view of what we want to achieve. Now to create a contour that we can use with a Z profile or a constant taper angle, we need the top edge of the curve rather than the bottom edge. So we know that it's 50 millimeters and it's 25 thick, so it's an angle of 45 degrees. So we just need to create some lines parallel to the bottom contour. So if I just minimize that, so what we'll do here is we'll just use the line command, parallel, and type in the value, and the same thing over here. And now we can do the same thing on the rads using the arc parallel to this one. So that arc is 100, so the larger one will be 150. And this one here is also 100, so that one will be 50. Okay, so now we need to extend these lines back to where they hit the vertical. So to do that I use intersect, and I'm going to use the option clip first. So this will trim or extend the first item I choose to the second one. So this is the first item, so that gets extended to the second item. First item, second item. Okay, so that's the line that we're going to create the contour with. So we go into NC contours. We can see that the datum position here is in the center of this part of the shape. If we wanted to, we could create another datum point either at the extents here or the extents the other end, just using the basic drawing techniques. Okay, so let's create this contour. So I'm in NC mode, so I go to contour, and then we'll start off over here. Now one thing when we're doing this is that under the general heading here, normally the shape is closed, but that needs to be unchecked. The depth of the contour will be 25 millimeters, and I click OK. Now because the contour is not closed, the help at the bottom says indicate the end point of this contour profile. So this is this one here. So that one has created that contour, which is here. Okay, so let's save that away and go into the machining. Save as. Okay, so we'll save that away and take that into the milling module. Okay, the machine setup, the first thing is to check on the tool change position. This is the X, Y, Z for where the machine will start and where it will finish. The clearance plane is set to 50, and the feed change plane will set that default to 3 millimeters. Okay, so that's the shape that we want to machine. So we'll define a tool. So we're using a basic end mill, so we set the diameter as 25 millimeters. If we're using a tip radius, we set it there. So for this type of operation we can use a square-ended tool, a bull-nose tool as here, or we can use a ball-nose tool. So we'll use this one here. This is 25 millimeters. Then we'd use a tool change, M6, so we set the spindle speed and the feed rate for this tool, and if we want the coolant to be switched on, we'd do that here. So now we want to use a basic go round command. So the contour is the only one that's there, which is con 0. The depth doesn't really matter because this is going to be overridden by the Z profiling command, which we'll come to in a second. Let's sort out the approach and runoff. So we'll use approach, and we'll have a parallel approach and make this bigger than the tool size. So let's make that say 30 millimeters, so that the tool is starting away from the material. And the same with the runoff, we'll make that parallel, make it 30 millimeters. Okay, so in its simplest form then we could just need to set the offset, so that's going to be to the left. Okay, so that would be just machining that all the way around there. But we want to associate a Z profile with that. So if we go back into the go round command, double click that and go to the Z axis tab, then we can either use a Z profile if the angle wasn't a simple angle. If it was a particular shape, then we would draw a profile for that shape. But if it's just a constant taper angle, we don't need to draw a 45-degree line. We can just click the constant taper angle here, and we'll set the angle to 45 degrees, and then in the cut depth section at the bottom here we set the step downs that we want. So we'll have 1 millimeter. So we click OK and then run that, and we can see that that's machined there. Now what that's doing is machining each 1 millimeter step and then retracting at rapid, back over at rapid, down to the clearance plane at rapid and the feed change plane, and then it continues to cut. Now that's okay, but we might want to get rid of these rapid motions here. So if we, to do that, we go to the go round command, and under the options tab right at the bottom here there's a switch which is reverse direction on alternate cutting passes if the machine is if the contour is open. So if we click on that, click OK and then run that, so what we get then is we get the tool running along the span. As you can see, that's a 25mm tool, so this is quite a large component. And then the tool comes back. So if I just stop that, go back into plan view and run the tool center line, you can see that the tool is starting quite a ways away. That's the approach, and this is the runoff command over here. If we look at it from the end view and then run, we can see the effect of that 1 millimeter step all the way down there. Okay, so that's how we machine that. We can then post-process that and use the 3D simulation module which is available in Mill Standard.